Hello, students. I'm your coding teacher and mentor. My name is Sonia Malik, and I will be teaching you C++ language, data structures and algorithm, and project work. So, in this session, you will be seeing various data types in C++. For example, I have highlighted here integer, char, boolean, etc. As per user requirements, you can use different data types. Okay, these are one of the most important concept of C++ language and helps you to solve various coding problems. So this is the index, like it is a timestamp on which timestamp you will be getting which kind of topic. So I hope you will like the video, go through it. Thank you. Hello, students. I welcome you all to the new session. In the previous session, we have covered basic structure of C++ language. And in today's session, we will be covering data types, data types in C++ language, right? Yes. So before proceeding further, I would like to ask you all what is the data? Okay. Data can be any sort of information. Data can be any sort of information on this planet Earth. My name is Sonia Malik. It is a data. Suppose I have I have 34 roll number in my college. It is a data. Everything is a data. If suppose my favorite fruit is apple, it is a data. Everything is a data. Your school name in which you're studying, your college name in which you're studying is a data, right? And to store this data, we have different data types in C language, in C++ language, actually, right? Some of the data types are integer. What does this integer data type do? It stores integer values. Suppose 10, 34, 5, 6, 7, 8, etc. Some more data types is character. What does this character data types do? It stores characters. Suppose it stores S, it stores Z, it stores Q, etc. Although we will be discussing each and every data type in detail in this session only, in later part of the video, right? Okay. So data types can be of two types. Data types are of two types. Two types. What are these two types? One is primitive data type. Primitive data type. One is primitive data type. Another one is your non-primitive data type. Non-primitive data type, right? Some examples of primitive data type is your integer, your char, your double, which stores decimal values, your boolean. We will be covering each of these data types in the later part. Don't worry. And some examples of your known data types is your name, your college name, right? It means string, arrays, etc. String is a collection of characters. Arrays is a collection of integers. Okay? Okay. So there is a popular saying in terms of programming that primitive data types are the building blocks. Yes, building blocks of non-primitive data types. What do you mean by this line? Like why the primitive data types are called as the building blocks of non-primitive data types? To demonstrate you, I would like to give you an example. Like in science, we have atoms. We have atoms. Atom 1 plus atom 2. Atoms combine to give molecules, which further combines to give you compounds. Like a compound is made up of group of a collection of atoms and molecules. Same way, your primitive data types combines together to form your non-primitive data types. right? That's why they are known as the building blocks. For example, in order to form Sonia, which is a string, and string is a non-primitive data type, it consists of five characters: S, comma, O, comma, Sonia. What are these Sonia? These are the five characters. These are the five characters. They combined, they combined to form my name, Sonia. Another example is an array. Suppose I have a collection of integers 10, 20, 30, 40, 50. It is an array which is a non-primitive data type, and 10 integers combined to form this array. What are all these 10 integers? 10, 20, 30, 40, 50. These five, sorry, 10 not 10, five integers combined to form this array of size 5. So every primitive data type is consisting of collection of or groups of primitive data types. Every non-primitive data types is consisting of collection or groups of primitive data types. That's why primitive data types are known as the building blocks of your non-primitive data types. Right? Okay. So let me erase it off and we will proceed to the next topic. Before making you aware of data types in C++, I would like to make you familiar with some concept that is bits. What is a bit? It is a format in which computer interprets the data. It is a consisting of two digit only, 0 or 1. Bit can be 0 or 1. Okay. Suppose I have given computer the number 5. What do you think? Like, what will computer do with this? Does it like it will it process 5 only, or it will convert into some other format or as per its own convenience? We have given the number 5 as per our convenience, but computer will interpret it in terms of collection of bits. How? 5 is represented as 101 in the binary format. How this 101 will give back the decimal number 5? Let us see this. Okay. You have to start from this rightmost side. Okay. Rightmost one. This one will be multiplied by 2 to the power 0. It will give you 1 into 2 to the power 0 is 1. 1 into 1 is 1. Okay. Plus. Then is your 0. 0 will be multiplied by 2 to the power 1. 1 power, increment of 1 power than previous power. Previous power was 0. Now your power is 1. It will give you 0 because 0 into something is 0. Again a plus. Then leftmost one is 1. It is multiplied to 2 to the power 2. It will give you 1 into 4, that is 4. So what does this number become? 1 plus 0 plus 4. It becomes your 5. This is how we converted a decimal into binary and a binary into decimal. Like I basically taught you how to convert a binary number into a decimal number. This is the concept of bits. Okay. Bits can be any collection. Like if I say 0 1 1 0 0 1 1 1 1 0 like that. This is a collection of bits. These are the various bits. I think there are 15 to 16 bits. This will form some XYZ number. It will take very long to calculate this number here in the session. So you guys can try it later, like what this number will give you. It will give some XYZ number. It is just a demonstration like XYZ. Okay. So every number, everything, every data can be represented in the form of bits. Character can also be represented in form of bits. Suppose my character, like I have taken A. The sky value, I would recommend you go to the Google, search out about a sky values of characters. A sky value of small a is 97, as I remember. This 97 also represented in the form of bits 01100, something like that. Okay? Yeah. This is the random 01 bits I have given, but I am saying that character is first converted to the sky value and then converted to the bits and then interpreted by the computer. Digits can be directly converted to the digits. This is digit 5. It is directly converted to the bits. But your character, suppose you have given I love playing chess. This I love playing chess will be converted to SKY values first. I SKY value, then space, then L SKY value, O SKY value, right? Like that. And then it will be converted to the bits format. Right? Okay. Okay. So I hope this bits concept is clear to you. It's just the basic thing that I want to tell you. It's not going very deep in it, but I wanted to show you like how a number can be represented into bits format. Okay. Next side concept is your byte. Okay. And in one byte, you have 8 bits. In one byte, you have 8 bits. 8 bits. Right? Okay. What I'm saying, 8-bit means initially it will be like okay. So 8 bits means 0 1 1 0 1 1 0 0 something like that. These are the 8 bits. I'm not sure like what number it will give you, what number it will give you in decimal form, but I'm saying like a byte can only consist of 8 bits, right? Something like 0 1 1 0 0 something like that. Okay. What is the minimum range? Like what is the range? What minimum value can this byte form from 8 bits? Minimum value, this one byte forms from 8 bits. Any idea like what minimum value? Okay, you are aware that now one byte is equal to 8 bits. I want to ask you like out of these 8 bits, like from this 8 bits, what is the minimum value we can get? We can get 0. How? When all the bits are 0. 1 0 2 0 3 0 4 0 5 0 6 0 7 0 8 0. These are the 8 bits and every bit is a 0. And the number formed in the decimal format is 0. Right? The number formed in decimal format is 0. Now another question is what maximum value you can form from this 8 bits? What maximum value you can form from this 8 bits? Maximum value of one byte can be what? It is when it is, I would like to give you a hint, it is when all are ones. 1 1 1 3 1 4 1 5 1 6 1 7 1 8 1. When all are ones, right? This is the maximum range it can go. And in between it is somewhere it is 0 0 1 0 1 1 0 like that. Okay. So the maximum value it can form is 0 minimum value it can form is 0, maximum is 0 to 255, that is 255. When all are ones, calculated in your copy and pen and see if we put all ones and calculate it using 2 to the power something that I told you in the previous part is giving you 255 or not. So what like total number is 256, right? 256 numbers you can form from this one byte. 0 to 255 is your total 256 numbers. There are two concepts. One is signed, another one is unsigned. What do you mean by this? Signed bit and unsigned, signed byte and unsigned byte? Two types of byte are there. Signed byte and unsigned byte. What do you mean by these signed and unsigned? Okay. Signed byte is when you have half negative numbers and half positive numbers, right? Half negative numbers, half positive numbers. It ranges from minus 128 to 127. plus of 127. 0 total we have 255 ranges. If you total this, you will get this 255, right? Some are negative, half are negative, half are positive. Sign means if you have some range from 0 to 255, half of 255 will be negative, half of 255 will be positive. This is what do you mean by signed. But when we talk about unsigned, when we talk about unsigned, they are having all positives, that is from 0 to 255, right? 0 to 255, they are having all positives. Sign means half positive, half negative. Unsigned means all positives, right? I am sure now you are comfortable with this concept of byte. 1 byte is equal to 8 bits. 2 byte is equal to 16 bits. 3 byte is equal to 8 into 3, that is 24. 4 byte is equal to 32 bits. Similarly goes on, right? Okay. So let me erase it off. Now the first and like the foremost first data type that I was talking about, like, okay, in this lecture I will teach you data types. So let me introduce you to the first data type in C++. Can you all guess what this first data type is? It can be anything, int, char, boolean, but the first one that I will teach you is boolean data type. Boolean data type. It is in short form, it is like we all are having short names now. Someone calls you, your name is 10 characters long, someone calls you for 4 to 5 characters, like in someone have your pet name, short name, you also having your pet name. Similarly, this boolean is also known as bool. Bool is a pet name of this boolean data type. We call it as bool, and it is also written as bool int a is equal to something. It is written as bool, and the full form is boolean, right? Okay. What is this boolean data type is all about? It gives two possibilities. It gives two possibilities. What two possibilities it gives you? Whether something will happen, something will happen, something will not happen. It gives you two possibilities of happening a thing or not happening a thing, right? Like a situation is given to you and you have to tell if it can happen or it cannot happen, right? Okay. Suppose if I say you, okay, my age is some XYZ, can I again turn into a 1 year old girl? What you will say in this situation? You will say, no, ma'am, you cannot. Now you cannot be a 1 year old kid. So there is a no. Okay. Yes. So something will happen, something will not happen. There are two values given to this Boolean data type. One is true, which is also known as 1 as integer format. Another one is false in string format and 0 in integer format. You can give a true or false, or you can give a 1 0, right? Okay. So I would like to give you an example to show, to demonstrate. I will demonstrate this data type with some example. With example, right? What is this example? I told you to check if 10 is divisible by 2 or not. I have given you this question to check if 10 is divisible by 2 or not. What you will do? What you will do? I will be using a if else condition in this. I know that I have not taught you if else condition till now. Just forgot about the syntax of if else. Focus on this logic that I am gonna say you. I am not gonna teach you if else in this video. It will be in a separate video, but try to focus on the logic that I'm telling you, not the if else syntax. Okay. If I'm checking if n modulo 2 equal to 0, return true. Not return actually, see out, because in main you can only print the things, not return. See out, see out, true. Else, see out, false. Right? Okay. So shall we test this code? Like we can check this code running RF11 key. See what it will give. Okay, it will give us it is giving us true. It means 10 is divisible by 2. So I have checked, I have given my computer some situation and he is responding in terms of yes or no. Right? If 10 is divisible by 2, if 10 is not divisible by 2, right? Okay. So this way you can check conditions. What it will return you? It will return you either true or false, right? Okay. Okay. I hope by this point you can check anything. You can also check, this is homework, you try it yourself. Like, just say it in your mind if it is a true or false. Check if small a is same as, yani ki is means it equals to capital A or not. Just say it loud on your own. Whether it you will give it as a boolean value as a true or false. Check if a small a is same as capital A. And I have already told you that C++ is a very case sensitive language. I have given you such a large hint. Now it's your homework to say it loud on your own whether it will be a true or false. We will be coding each and everything in the further sessions, right? Okay. So let me clear it off. Any possibility, like Boolean can include any possibility. Any possibility. Today it is raining, I have to go to college or not. Right, exact, like this. Two possibilities. One can be true, one can be false. This is your Boolean data type. Okay. Next data type is your character data type. Character data type. Can you tell what is the pet name of this character data type? It is char. Boolean is bool. Character is char. Okay. And you will write char, not character, while coding. Right? Okay. Okay. Character data type. Its size is okay. So, I forgot to tell you that. Wait. I forgot to tell you that Boolean data type size is what? Boolean data type size is 1 byte. Okay, because it represents two possibilities. For 0, all the bytes will be 0, 0, 0, 0, 0, 0, 0. 8 bytes will be all zeros. For 0 possibility, for false possibility, right? And for 1, that is true possibility, all 7 bytes will be 0 except for the last, sorry, bits will be 0, not bytes, bits will be 0 except the last bit. Everything will be 0, right? Okay. So Boolean data type size is 1 byte. In case of false, every bit is 0, every 8 bit is 0. And in case of true, every 7 bit is 0 except for the last bit. Because you know that 2 to the power 0 into 1 is 1. Okay? Okay. Next data type is character data type. Character data type. It is popularly known as char. What is the size of this character data type? Size is 1 byte. Because every character, like what do you mean by a character first? Then we will proceed to its size, why it is 1 byte. What is a character? From small a to small z, these all are your lowercase characters. Lowercase are the small characters, lowercase characters in English alphabets, right? Your capital A to capital Z is also a range of characters. It is known as uppercase. Apart from it, what can you consider as a character? The various keys that you are seeing on your keyboard, on your laptop's keyboard, on your desktop's keyboard are all the characters. For example, at the rate, dollar sign, percentage sign, ampersand sign, asterisk, left round braces, right round braces, minus sign, underscore sign, plus sign, equal to sign, etc. The various characters that you can see on your laptop's keyboard are all the characters, not just small a to small z or capital A to capital Z. These all are your characters, and they have some sky values. As Google it out, like what is a sky value and what are the various sky values. Okay, yeah. Small a to small z are having sky values in the range 97 to 125, I guess. Yeah, they are having like this. Okay. Why its size is 1 byte? Size of character is 1 byte because I already told you that character is first converted to the sky value and then sky value to the bits. Right? In the previous session, in the previous part, I told you. So every character first converted to the sky value, and their sky value will form within the range of 1 byte. That is, with the help of 8 bits, with the help of 8 bits only, we can represent all the characters. That's why its size is 1 byte. We can represent a sky value of every character in terms of 8 bits. That's why it is sizing of its size is 1 byte. 1 byte is equal to 8 bits because sky values can fit in this range only. Right? Okay. I hope this is clear to you. Okay. For what is a sky value? You can Google it out. Right? Okay. The next data, I hope you all are very much familiar with character data type. In order to give you an example, suppose I'm taking hello string. It has 5 characters HELLO. Characters can form any name, your address, where you live, your college name is also formed of characters. Suppose I'm having uh, some school name, just recall your own school name in your minds and see, like, they're also consisting of some characters. Every naming thing, like if I'm having T consists of TEA, 3 characters. If I'm having, I'm saying, okay, I'm having heater. Heater is consisting of 6 characters HEATER. So these are the characters that are making these strings or strings like thing, addresses, college names, and etc. Right? I hope you are familiar with this character data type. Its syntax is char, any variable name you can give. I'm giving it ch because in programming world, ch is very much readable by programmers. Okay, ch means character, char ka adha ch. Character ch is equal to a, and I will see out this ch. Let us see what we will get. Okay, we will get a because we have given it a only, right? Okay, this is the syntax to print a character. First, char is the data type, then any variable name. I have told you the naming conventions for giving this variable name. It cannot be anything. It is something which is easily readable by the user. And this a is the part which is located on the right hand side of this equal to sign is your value. So you have data type. See my cursor. You have data type, you have variable name, you have value, right? Okay. Okay. So let us proceed to the next data type, that is integer data type. Now again you will ask, ma'am, is this also having a pet name? I'll say yes. It is having a pet name. It is called as int. It is having a pet name as int. What it what size it can store? Its size is of 2 bytes in some compilers or 4 bytes. Its size can be of 2 bytes or 4 bytes. It depends upon the compiler that you're using, right? But more familiarly it is of 4 bytes. Okay, more familiarly it is of 4 bytes. right? Right. Okay. So what do you mean by 2 bytes? 2 byte means 16 bits. 16 bits. It means 16 bits. What is the minimum value you can form? Minimum value you can form from 16 bits. Minimum value you can form from 16 bits is your 0. How? 16 zeros. 10, 20, 30, 40, 50, 60, 70, 80, 90, 10, 0, 11, 0, 12, 0, 13, 0, 14, 0, 15, 0, 16, 0. All are zeros. All 16 bits are 0. Let me separate it because otherwise you will feel confused. Okay. 8 bits on the left side and 8 bits on the right side. This is 2 bytes when the integer is of integer has 2 bytes. I told na somewhere it is having 2 byte size or somewhere it is having as per compiler dependency it is 4 bytes. For 2 bytes we have 8 bits in one part, 8 bits in another part. So the minimum value it can give you by this 16 bits is 0 when every 16 bit is your 0, 8 bits 0, 8 bits 0, right? Okay, so my another question is what is the maximum value you can form from 16 bits? It means 2 bytes. What is the maximum value you can form? It will not possible you to compute in this live session in this class. Please do try it on your copy and pens, like what will be the maximum value. For now I will be telling you the maximum value you can form from this is 65535. Yes, yes, my dear students, 65535. How? When all are 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. When all 16 bits are your 1 1, the maximum value you can form is 0 to 65535. 0 when all are 0, 16 bits are 0, 65535 when all 16 bits are 1, right? This is the maximum value you can form from 16 bits, right? Okay. Now what if size is 4 bytes? What is size of integer is 4 bytes? We have already talked about 2 bits, 2 byte size. Now what is 4 bytes? 4 bytes is 32 bits. 4 bytes is 32 bits. Again my question will be same. What is the minimum value you can form? Minimum value you can form from this 32 bits? It's 0. How? When all the 32 bits are your all the 32 bits are your 0 0. These are the 32 bits. 8 bit, 8 bit, another set of 8 bit, another set of 8 bit. Okay, so minimum value you can form is this 0. What is the maximum value you can form? Maximum value you can form, it is very large number, you cannot even guess it, right? Okay, even I will not be able to tell you the entire one. It is search it out on Google. It is 447. Okay, my bad, I'm writing on top. It is something 4477 dash 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 dash, something like that. It is something like that. It is something like 8 to 9 characters long, 447, something like that. This is the maximum value you can form from this 4 byte when all the bits are 1. How you can form this? When all the bits are 1. Okay, when all the bits are 1, you can form this maximum range value. Now again, it also has some concepts of signed and unsigned. I know it will be now very easy for you to segregate what is signed, what is unsigned. So, unsigned means 0 to 65535 range. Okay. Unsigned means, what do you mean by unsigned? All are positive. It means the range is from 0 to 65535. Right? What do you mean by signed? When half of the range is negative, half of the range is positive. Half of 65535 is, it is from -32768 to 32767, right? Half are negative, half are positive. Again, same thing in 4 bytes integer. What is signed value? Signed value is from minus 2147 something, something to, or something. I'm writing this hashtag, okay, bear with me. Something to plus of 2147 something, half negative half positive, because total is 417. Half of this is half negative and half positive. And for unsigned 4 byte integer value is 0 to 447. The larger, that I told you that it is very large, it is this number, it is this number. Let me write this only, not exactly this number but something like that. Okay. The way of telling you this thing is, just I want to tell you that you have two types of ranges, signed and unsigned. In unsigned you are having all are positive from 0 to the when all are ones, right? This range that I taught you. But for unsigned, half are positive, half are negative. That's the ultimate concept of signed and unsigned. Don't get yourself confused by this signed and unsigned much, because majorly your int is used rather than signed int or unsigned int, right? Some examples of integers are 10, 45. Tell me your roll number. I assume your roll number is 56 in your class. 56 also an integer. Okay. Yeah, 56 is also an integer, right? Okay. So this is the integer concept. This is the integer concept. Yes, minus 1 is also an integer. Minus 2 is also an integer because it has range from minus also. Yeah. When you're not mentioning signed and unsigned, it takes negative and positive values both, right? So let me clear this div C++ again for the next concept. Next concept is your long. Long is same as int. What is the difference between long has no pet name because it is such a short long, just 4 characters long. Long is same as int. Long is same as int. Int is declared saying int num is equal to 10. Long is also declared same way. Long num is equal to 10. Then if these are same, why these are having different names? Wow, what a rhyme. Like why, if these are same, why they are having different name? Right? Right? Okay. So why they're having different name is because the ranges they store differs. Int stores, okay, for some compilers long is having 4 byte size, and for some compiler long can have 6 byte size, right? 4 byte and 6 byte. Okay. So in some cases long stores greater value as compared to int. That's the difference. Same way you have long. It stores large value, 10 to the power 18, or very, very huge value. I'll give you a very great example. Just bear with me for 2 minutes. I'll explain you all these things together, right? So you can judge between like which data structure does what. You can easily compare between these three, int, long, and long. The main difference in int, long, and long is the sizes they can store. Int can store your mobile number maybe. Long can store your Aadhaar card number. And even if the number is very large, some very large number, then only long can handle it. Neither your int can store it, nor your long can store it. It is about the storage difference. Long can store some quite high values than int. Long can store even high values than long, like that. Okay. Okay. Long data type sizes. Long size is 8 bytes. As you can see, 8 bytes is quite larger than previous two. So I can say your int is smaller than your long in terms of size, and long is greater than your long. This is the greater than sign I can give you. Like this is the greater than sequence I have generated. Int is smaller than long or equal to in some compilers, but long cannot be equal to long. Long is the greatest one, right? Okay. Suppose I am giving you some number. Suppose some mobile number is 1. Suppose mobile number is 9671234567. Let us see if int can store this number or not. if it will give some error or not. Oh, my bad. Oh, see what happened. Magic happened. In the error box, it is showing overflow in implicit constant conversion. When you see this word overflow, it means you are storing something a large number. My dear friend, int cannot handle this number. Compiler is saying to you, कि hey Sonia, you have given such a large number that integer data type cannot store it. Give something small. It is overflowing. Suppose you are having a glass, you want to drink some water from your RO, right? You are filling the water and then your glass has reached the brim. It is filled, but still you're pouring water into it. It means it will overflow because glass has a fixed capacity to store the water. Same way, int is also having some capacity to store the data. You are giving the data limit beyond its capacity. It is not taking it. That's why. And you can see that in the output box, some value is printed. This is a garbage value, corrupted value. When your integer is not able to store a data that you provides due to it is beyond its capacity, then it will behave like this. It will print garbage values, very different values, very unwanted values, very garbage values. If I reduce some, if I delete three characters from back, let us see if it can store this or not. Wow, amazing, it can store this 9671234, right? We have seen like how int will behave if the value given is very large. Let us check the same thing on long data type. Let us bring back all those three values that were deleted previously. Let us see if long will able to store it or not. Oh, it is also giving overflow and giving the corrupted value. It means long also is the brother of integer. It is also 4 byte. It cannot handle this value. Let us delete three values. Here the long size is 4 byte, similar to that of integer, but in some compilers it can be 6 bytes also. If the long would have been of 6 bytes, it would have stored this extra three numbers, this whole number. But here the long size is equal to the integer size, that is 4 bytes. That's why it is also giving the same error, overflow. It cannot also store data beyond its capacity. Let us give something long. Let us check if long can store this value or not. Wow, long can store this large value. Have you seen the difference? Integer was not able to store the value because of 4 byte size. Long was also not able to store the same value because of 4 byte size, but long has 8 bytes to store. So it is very easily storing all of these big number. If I'll give many big number like 5 fives or something like that, let us see if long can store this or not. Oh, it is giving us some error. It is showing, it is giving us some garbage value, and it is it is giving us error. It means this value is quite large for long to store. Yeah, long can store greater values than integer and long data type, but not that much long value. Let us reduce some of the size and then check if long can store this or not. Again, it is giving me some corrupted value. Let us decrease some more size and see if it can store or not. Oh, again it is giving, it means I have to reduce more numbers. Let us see if this can store it or not. Boom. Wow, it can store these values. It means long is not having infinite size. Like I have initially given it very long number to check if it can store or not. But it is also having some capacity. Its capacity is greater than that of int and long, but its capacity is also limited. For integer and long, I have given you example of glass that treat integer and long as a glass. Long is a bucket. Okay. One time your bucket will also be filled if you continuously pour water and the water will overflow. Okay. Glass, like bucket is having larger size as compared to glass, but bucket is also having some capacity. So this is the concept. Long can store larger values than int and long, but it is also having some capacity. It cannot go beyond its capacity. I hope you all are clear with the concept of integer, long and long long. Okay. Now two more data types are left. Let us quickly cover them up. Another is double. It is also not having any pet name. It is double only. Double is another data type. Now you will see like most of the data type is already covered. What this data type is special all about, like what this does, what this double data type do. So in the video, like you like till now I have not told you any data type to store the decimal values. So double data types and float data types store the decimal values simultaneously. I'll teach them, they are also comparable, right? Double and float stores the decimal values. Then if both stores the decimal values, what is the difference between this double and float? Double is like a long. It stores quite larger decimal values as compared to float. Float stores smaller values as compared to double. Double stores larger decimal values. Float is like int or long, double is like long, right? It has 8 bytes storage size. It can store up to 8 bytes. Float can store up to 4 bytes as long and int. Float size is less than double in order to store the decimal values. How to represent this? Suppose, okay, let me take your oral test for this. Okay, I am giving you 34.5 and I am asking you like if it is a double or a float. Quickly answer me this question. In your minds, you can answer like it is a double or a float. You will say like, okay, double is also a decimal representation, float is also a decimal representation. How will we aware of like if it is a float or a double? In terms of float, you will write a f. Now, okay, you are very smart students. You will say we will identify by the data type. If the data type, suppose I am giving it deci, okay, you will say I we will see the data type. If it is a float data type, it is a float value. If it is a double data type, it is a double value. But I am saying you are not given the data type. You are given deci equal to 34.5, not float deci or double deci. Now how will you identify that it is a it is a float value or double value? So the representation is when it is a decimal value as a float data type, you will write a small f or a capital F or a 34.5 capital F. By writing this, anyone can know, oh, this is decimal value, but this is a float data type. This is a float data type, capital F or small f. For double, there is no need to write anything. Just simply write 34.5. Or if you wish to write something, you can write D, 34.5 D or 34.5 capital D. This can also be represented by this, right? So this is how you differentiate if the data type is not given, right? Okay. So let me demonstrate you by printing some numbers. Suppose I am giving 56.78 and I am printing this num. Let us see what it will give. Cool, it is giving you 56.78. Let us try with small f. What it will give? Wow, it is giving 56.78. It will not give you f. It's just to show. Okay, it will not give you f. It will give you 56.78 only. It is just to show that it is working with putting f and small f and capital F as a suffix. Same for double. Same for double. Let us print this. Now it is, okay, it is not giving any error. I thought it will give some error by this f. It is ignoring it basically. This is for our convenience that we are writing capital F, small f. Otherwise, float and double are ignoring this prefix, these characters. It's just for our own sake that we are, if we want to differentiate, we can see that if it is something D or something F. Otherwise, double and float will not give error. They will ignore this character at the end. They will just take 56.78, right? Let us try with capital D also. Now you will say that okay, if any character is acceptable, we can put a u here. Yeah, you can put a u here, but it will give some error, right? It will give some error. What is u, right? It is not accepting this. I want to check you like what you will think about this. It will not take it. Although it is ignoring this small and capital D while printing, but it will not ignore it when some other character is given, some y is given like that. Let us test. Okay. Yes. So it will print 56.78, but it is only accepting D, small d, and capital D, right? Otherwise, it will be something else, right? Okay. I'm sure you all are very much clear now with the concept of every data type that I have taught you. You will be getting more familiarity with all the data types when we will be coding it up, when we will be proceeding in the further lectures, coding it up, doing some numerical calculations, some coding questions, problem solving, etc. Then you will be getting very much good to go with all these data structures in practice. So I would just recommend you try it yourself. Try play with the ranges. Try giving every data type a different range and see if it can accept that those ranges or not, right? Yes. So that's all for this session. I hope you have gained some knowledge out of it. And yeah, that's the session is all about. Thank you, students, for joining in, and thank you for your time. Bye bye.